So what I wanted to focus on in today's talk is some work that we started as a bit of empirical work some time ago, looking at Facebook, and in particular looking at the spread of applications in Facebook, and then some much more recent work that's a counterpart to that, which looks at modeling the behavior that we've observed. And so why did we think this was an interesting environment to be studying? So by chance, back in 2007, one of the postdocs in my group said, oh, wouldn't it be interesting to look at Facebook apps and maybe we can study how they spread? And I must admit, to my shame, I looked at him very blankly because I had no idea what a Facebook app was. He was, of course, right, and so we set up a computer in the corner of the lab which just regularly downloaded some data on Facebook use. And the interesting question is in some sense summarized in this slide. So you have a world of users. It was a much smaller world back then. So this is a time when Facebook had 50 million users approximately. It's very different from the situation we find ourselves in now. The interface neither looked like it does on the screen in front of you, because we never thought to actually take a screenshot of that, nor does it look like this now. So some of the features were slightly different, but the key factor is that if you think about users choosing whether or not they want to download an app, then they in principle have two different kinds of information available to them. They can make use of local information, which would be, do my friends use something, use a particular application, and in fact, in some cases, and the example that's up here under local information on the left shows that there might be explicit externalities. So the app that is visible there is something called Movies, which compares your compatibility in film tastes with other people. This is quite entertaining because this was actually done with the co-author of my work, and as you can see, I appear there in his window, and it says terrible match. So clearly we had the right creative tension in the team. We obviously disagreed on what good films are or not, but the more serious point is obviously an app like that is not going to work if nobody else you know actually uses it. So there's an inbuilt network externality there. The more people you know who actually use it, the more utility you get out of the app. If you know nobody who uses that app, you get no utility out of it at all. So that would be something designed into the app. But additionally, you might simply have very similar tastes to your friends, or you might talk about apps and encourage them to use it. At the time that we collected the data, in fact, the interface was such that if you chose to install an app, then all of the people who were your Facebook friends were actually automatically notified, and that notification initially couldn't even be switched off. There's a very different kind of information that you could in principle use to guide you in deciding. That's global information, which is just ranking. So this is essentially the equivalent of a Sunday Times or New York Times bestseller list for books, except of course rather than giving the top 10, it goes all the way down. And so the question then is, you have a world of Facebook users who essentially can choose apps, and this is a system that you can collect very rich data on, which would be very difficult to do in analogous real-world situations. So why would we be interested? Well, one piece of work that certainly, I guess I should say, influenced us in that regard was the work by Matt Selganik with Peter Dodds and Duncan Watts that appeared in Science in 2006, which was about essentially a paper about teenagers who went to a portal, and from that portal then subjects for an experiment were recruited, and you looked as to how much they liked music in terms of how they scored it or even how they downloaded it, depending on what information they were presented on. So they might have and by way of background, these were very obscure bands. So these were not musical tracks people would have had prior experience of. And you found that if people knew how other people had chosen what they liked, so what was considered to be popular or not, that would very clearly influence their choices. And that's a very general phenomenon that's often associated with what are called cultural products, so that's books and films and so on, where there's a high level of uncertainty how to value them, where it is also known that social influence plays a very big role. And so Facebook apps seem to fall into a very similar category. So that was one reason we were interested. The other one, very briefly, is that one could also think of apps as a kind of an innovation. I know if you look at what they actually do, you might sort of wonder to what extent innovation is the right term to use, but you could think of it as an innovation, and there's a tremendous advantage because essentially in all of the classical work where we look at the spread of innovations, so the classic work going back to the 1950s, for instance, on the spread of a new antibiotic, work on, say, spread of hybrid corn, typically you look at one innovation rather than a family of competing innovations. There's a lot of selection bias, and it's also very difficult to control for external factors. So it's difficult to control for advertising, it's difficult to control for instance, the classic work, which looks at antibiotics, has now been called into questions because reanalysis has suggested that the actual activities of the company reps were not sufficiently taken into account. And that if you did that, then the sort of word-of-mouth transmission effect would actually become statistically insignificant. So that sort of broad motivation. What kind of data did we actually collect? So essentially the data we have, somewhere between big data and small data, it doesn't really qualify, is we looked at the roughly 2,700, and there were actually, I think, 2,720 applications, which we narrowed down because of data corruption issues to 2,705. And then what you can do is we basically looked every hour for every app how many installed users there were. So it's obviously a net outcome because some people might drop an application, some people might install an application. So the nature of the data is shown by this thing called movie applications, which we have for every, so on an hourly basis you have the number of users. What you of course have to remember is we started collecting this data very, very soon after apps were launched. That has a tremendous advantage because there was no great media coverage, there were no other influences that would be likely to have interfered. But of course, they weren't all introduced on day one. So obviously, you have apps that are gaining in popularity, but as you can see, you also have apps being introduced at different points in time. And what you can then do is you can look at activity patterns. So if, for instance, we have a number of users at a given time step who have installed the application I, then we can just look in the next time step how many users are there for that application. And then, as you can see, we can define for the application an activity which is just the difference in the number of installed users between the time steps. And then we can look at a total activity, which is a sum over all of the activities for the individual apps. And unsurprisingly, what you see is a overall aggregate growth, which is increasing. This is, after all, shortly after they were introduced. And unsurprisingly, you obviously also see a lot of diurnal fluctuations, because obviously people will, even the crazy people who play around in the early days with Facebook apps, presumably sleep at some point during the day. And from this, you can pull out these sorts of adoption dynamics. Some of them, so none of them look in this pure sigmoidal form like the sort of adoption curve you would see, because you get a very rapid onset. And in some cases, we see some slightly anomalous behavior where you see strange kinks, which in some cases seem to be related to versioning of the app, and in some cases are slightly mysterious. And so what you see on the bottom is simply what happens if we, and we'll come back to that, if you just superimpose either the activity patterns or these adoption dynamics onto each other. So if you sort of subtract the time of birth so that you all have them starting at a comparable time. And one of the things that very clearly, and this sort of links back to the Duncan Watts paper I mentioned in the beginning, that you see is you get this very long-tail distribution. So if you look at a Ziff plot in terms of popularity of the apps, and remember, this is at a time when there were 50 million users, then the most popular application has almost 12 million users, and then you very rapidly drop off. So the 10th most popular already has less than 5 million, and actually the most apps have something of order 10,000 or so installed users. And so we wanted to look at this. Just a quick reminder of what I said in words in the first slide about the structure of the information. And again, we're not going to make any assumptions. We're assuming that users are highly heterogeneous in how they use this information. So in some sense, what this is simply summarizing is a sort of information environment that the users sit in, and how and why they might pay attention to these. So there's both this local information I mentioned, there's the global information. You might pay attention to local popularity either because of similarity of taste with other users who are your friends, so some sort of homophily effect. You might pay attention to global popularity because it might be a signal of quality, or it might lower your search costs for good apps, or it might be some sort of signal for superior functionality. And so then you can think about how you might want to measure social influence, and the technique, and I will go through this quite quickly because it's the results that are the main thing I want to focus on. What one is interested in doing, and the key point you should have noticed by now is that from the nature of the data I described, we obviously don't have the network structure underlying how users are connected to each other. And so what we have here is we don't have data from the perspective of users, we have data from the perspective of apps, and we want to see to what extent we can push those data to see what we can understand about the observed behavior. And more specifically, what we'll be interested in doing is we'll want to look at the temporal correlation between installation activities. And the assumption here is that if you see a high level of correlation within a time interval of the installation of a number of apps, then you assume there is some kind of influence process at work there, in the sense that the installation activity of one user has affected another. The exact mechanism, of course, on the basis of the data we have, can't be discerned. So as before, we've got this net activity, so we can imagine users can either adopt or not adopt. Dropping is actually a very rare activity in this phase. Later it would become much more important, simply because this is the early growth phase of apps on Facebook. And what we can define here is both a mean of this time activity series, mu, and then a standard deviation of the activity series. And we can then, the technique we'll be using, and here I will cheat because he's sitting here so conveniently, anybody who wants to know anything about temporal fluctuation scaling, just ask Janos, because he's co-authored a really good review paper on that. The main point is what we see when we get to the bottom, which is that my expectation under certain assumptions is that I would have a power law relationship between what we see here, which is the standard deviation of the time activity series given here at the bottom, and f of I. And the key observation is the following. So if I now were to plot on a log-log scale, so I'm assuming that I've got this power law relationship. So therefore, if I plot the standard deviation versus the mean for the activity, for this time series activity as defined at the bottom there, then there are two limits that are quite informative. The one is if I have an exponent of alpha equals a half, that would suggest that I have no temporal correlations in my time series. If I have an exponent of alpha equals 1, then I would assume that I have a very high level of correlation. So what do we actually find empirically? Well, what we find empirically is that we have two quite distinct regimes. We have one regime with the exponent quite close to the value we would expect with no correlations, so extremely weak correlations. That's alpha equals 0.55. And then we have a breakpoint and then a transition to a second part of the regime where it's not exactly equal to 1, but we have a quite high level of correlation. And obviously, I don't think this is particularly meaningful because it will depend on system size and a number of things. But broadly speaking, that transition point corresponds to a particular daily rate of install. So you can translate that transition point into a daily rate of installs, which is about 55 installations per day. And so what you have here is a sort of an on-off behavior where either the effect of other users on your installation decisions is negligible or it is very strong. And you don't have a gradual transition between the two. So social influence either plays a role or not, which means that in some sense, if some sort of fluctuation propels you up to a point where you are growing fast enough, then you might be gaining the critical mass to be getting into this collective regime. One question we ask is, does age matter? Does the age of the app matter? And we've done it in different ways, but a visual way you can answer that is simply by looking where in this diagram apps of different age sit. And as we can see, even just visually, for the 3 different color-coded age ranges, we pretty much see apps across the entire plane. So this is not an age effect. One of the things we did do is we did obviously it's observational data, so there's a limit to what you can do. We did a particular sort of reshuffling of the time series. And what that allows, when you reshuffle the time series, you find that this transition actually vanishes. And that suggests, among other things, is not a density effect, because the density in terms of total number is actually preserved. So now the question is, we know there's a social influence effect. We can see that there's a social influence effect that comes on and off. But really, we have no idea, because of the nature of the data we have, what mechanisms might cause that. It could be a local effect, it could be a global effect. You could imagine a number of different mechanisms. And the classic answer to the question of how might one find out more would be in line with this really nice paper that was done by Bond and James Fowler and a few people that appeared in Nature in 2012, where essentially what they did, and this was done in collaboration with Facebook, they looked at the degree, this is during the Obama's second presidential election campaign, they looked at the degree to which people influenced each other in terms of voter registration. Now this is a controlled experiment where you have some people who are exposed to certain information, some are not, and typically that would be held up as a gold standard for what you would need to do to actually intelligibly say something about mechanisms. So the question that somehow irritated us from the beginning is, when we started working on what we're working, we really were keen to do a paper that would be both empirical and modeling. And eventually we gave up on the modeling, at least in the first phase, but then we came back to it. And so the model that we have now applied to try to understand the observed behavior we see in the Facebook data is one where we're essentially looking at 2 kinds of ingredients in this generative model. The one is largely a preferential attachment model. I should add, this isn't shown I think in the next figure, we can modify that to have a fitness, so it could also be a preferential attachment mechanism. So this would be popularity dynamics. I preferentially install the app with the most users. And the other is a mechanism where you pay attention to recent activity. So I don't necessarily care that this is the most popular app in the world, but if Janusz has just installed it, for instance, then it's much more likely I will install it as well. And we then essentially build a simulation that implements this model, where on the left you have the data, and then we seed the simulation initially with the empirical data. So in some sense you're training on the data in the beginning, and then you see how the simulation continues on. And what you find is that, so you have a number of parameters you can tune. So what you're doing, the 2 main ingredients, just to be clear here, are preferential attachment on the one hand and an imitation effect, and in particular an imitation effect with a particular memory function as a second, and then you basically combine these 2 mechanisms. And if you look at the long-term behavior of the system, then you cannot choose between any of this family of models very well, because with appropriate choice of parameters, the models typically fit the data very well. However, if you then try to model the dynamic evolution that you observe in detail, you find that you are actually able to discriminate much more clearly between these competing models. An effect that I will just mention in passing, because my time is coming to an end shortly, is that one of the anomalies we find we have to correct for is that there is something different about how applications behave in the very initial phase. So there's a sort of novelty regime. And the other thing is that in all of the slides before, we have to truncate the data because in some sense, we in terms of the empirical data, we can understand what happens best when we have applications that were actually launched during the observation period. Because obviously, if we have applications that were launched before the observation period, then we're missing the early bit of the dynamics. So we need, in some sense, we look at a subset of apps where they were launched within the observation window, so they're after the beginning of the observation window, but they have enough time to run before the end of the observation window so that we can collect a lot of data. And the key things that we find here is, as I say, that we suddenly find that when we do the detailed modeling across a parameter space, then we actually can see that rather than being unable to distinguish between these models, we very clearly, for instance, see that a model where copying with an appropriately chosen memory function in all cases outperforms preferential attachment and explains the data far, far better. And then final thing, simply because from CASA we had all of these wonderful pictures, I just wanted to say 2 words about each of these slides. In terms of computational social science, one of the things that we're kind of interested in doing is looking at our ability to look at small data sets. So at the top, we've got mobile phone use between approximately 25 people over 18 months. This is work that came out in January, which has led us to see that there are certain regularities to do with people's social networks. And we're now trying to see to what extent that allows us to decode features in a much larger data set of about 7 million people, where we, however, have far less information about the individuals. And the other gratuitous picture, which looks a bit like some of the CASA pictures, just something else you can do with spatial data. What you see here is a city in Sierra Leone, and the dots on the map are borrowers who are taking out microloans from a particular foundation as groups. Turns out that the spatial, even if you control for different areas, et cetera, the spatial configuration of the individuals in these groups is highly predictive of how they do in these lending groups. Thanks very much.
Thank you. Questions, remarks, comments, please?
I just wanted to make sure that I understood correctly. So in this, you're emphasizing the role of social influence, but you didn't account for any offline factors, like somebody's friend telling them about it or media coverage or anything like that.
Well, we can't, we don't directly, even within Facebook, we can't look at direct social influence because we don't have the network. So I don't know X is friends with Y. And obviously there will be other channels through which people interact. So it is simply on the basis of the time series behavior, picking up whether, because there's this clustering and sort of time series activity, whether it's likely or not that there was influence. Now some of that may arise randomly, but beyond a certain measure, if you see a highly clustered sort of time series, you would assume there is some kind of influence effect.
So there's correlation, but the influence effect could be offline.
Absolutely.
I have a question. You consider all the apps as independent from each other, although they may have interactions. Don't you think that the model is able to incorporate such app interactions? I mean that some apps cover similar activities than others, and then switching is a very natural
Yes,
thing.
I mean there's 2 things we in a rough and ready way looked at rather than in a completely systematic way. The one thing is we tried to see to what extent if you took 100 apps that had very obvious network externalities, with a slightly different point in them, and compared them to ones that didn't. So an example is, for instance, I think there's an app called Lava Lamp for people who feel nostalgic about the 70s. You know, and presumably your enjoyment of that doesn't require anybody else to have it, whereas all of the things that involve comparisons or playing games with somebody else does. There we saw no differences. And also we looked at, for a subset, we did categorization by type. So for instance, there's a number of movie application ones, there's a number of horoscope ones, and so on. And when you did it by type, so there wasn't any particularly systematic. So it wasn't that horoscopes were all elevated. So there's, for instance, one horoscope one that's quite high up. But that doesn't make it being a horoscope app particularly predictive of whether it will be successful or not.